And work 4, solving systems of equations by graphing and substitution. So our first set is solving by graphing. So we are looking at number 1 first. Solving each system means that you're finding the one ordered pair that's a solution to both of the equations that you're dealing with. Remember, most of the situations we've seen, there is one ordered pair, and when you're looking at graphs, that would be that one point where they intersect. There is also the possibility that you have infinitely many solutions, or all reals, or no solution. And that would be lines that are actually the exact same line, or lines that run parallel to each other. But more often than not, they do tend to not be parallel and they intersect each other. So these two right here, we're going to graph them just the same way that we did earlier in the chapter a couple days ago. So this one, you've got a y-intercept of 1. So we're going to start with that. So y-intercept of 1 gets plotted right there. And then this, our slope is 1 over 4. So think of rise over run. You rise 1, run 4. So from this point, we're going to rise 1, run 4. And this, remember when we were graphing these, I told you 2 points was plenty accurate to do a line. With this, we are looking for something very specific. The graph is not the end goal here. The intersection point is the end goal. So we want to make sure we fill the entire graph with completely accurate points. So I'm going to go up 1 over 4 until I hit the end of this graph, and then I'm going to do the same back in the other direction. So that would be down 1, to the left 4, and you can do that till we would run off the graph. All right, so connect the dots here so that we're able to see exactly where these two lines intersect each other. Second one, negative x minus 9. So this right here would be our y-intercepts, and then this would be our slope. Okay, so negative 9 right there is going to be our y-intercept, and then our slope is a negative 1. So that means we can go down 1 to the right 1, and we run out of graph here, so we're going to immediately start going the same in the opposite direction. So instead of going down and to the right, we could also go up and to the left. So I'm going to do that over and over and over again until I run into the other line. And you want to make sure that it's accurate so you know exactly where they're intersecting. So when I'm going just up 1 over 1, that means I'm going through each one of these corners here. So you want to just keep doing that until we see where they intersect each other, or you run out of graph. So connect the dots here, and you can see we've got this one intersection point right here. So clearly identify your solution. That just means make sure you're writing down the ordered pair. This graph itself is not enough. That would not be an answer for me on a test. So make sure you're writing down the ordered pair. So if we see where this intersection point is, count over, that would be a negative 8, and then down at a negative 1. Okay, so negative 8 is the x coordinate, negative 1 is the y coordinate, and we want to make sure that that ordered pair is what stands out as your actual answer. Okay, so the rest of those are solved by graphing. And then this one, we are doing the substitution method. So I give you guys a 4-step process for the substitution method. Step number 1 was solve one of the equations for x or for y, or in other words, isolate one of the variables. So you can see here that both of these equations are actually already isolated for y. Okay. Step 2, substitute the resulting equation from step 1 into the other equation for that variable. Okay, so this one's kind of nicely set up already to just do a good substitution. So this one says that y is equal to negative 2x plus 14, and so then my second equation has a y in it. So what I'm doing is I'm going to take this y in the second equation, and I'm going to sub this expression in for that y. Okay, so if we use equation number 1, this says y equals negative 2x plus 14, which basically means they are interchangeable. If y is equal to negative 2x plus 14, that means y can be replaced with negative 2x plus 14. So we are going to replace this y with negative 2x plus 14. And then the right-hand side of the equation will stay the exact same. So that's step 2. We make that substitution. Step 3, solve for the remaining variable. So the remaining variable here is the x. We're going to do a couple steps to get the x by itself, just like we were doing in chapter 1. So here, I want to get the x's on my left-hand side. So I'm going to subtract 5x from both sides. So negative 2x minus 5x is negative 7x. And there's still a 14 here. When I subtract 5x from the right, all that's left behind is this negative 7. And then to get the x by itself, I should also subtract this 14 over to the right. So when I subtract the 14, it leaves my x's alone, and then subtract the 14 from a negative 7. So negative 7 minus 14 is a negative 21. Last piece here is to divide both sides of the equation by negative 7. So when I divide this by negative 7, the x is by itself. Negative 21 divided by negative 7 comes out as a 3. So that's half your answer. It should always be an ordered pair. So step 4 is to substitute your answer from step 3 into either original equation to find the other variable. So you can take x equals 3 and sub it in here, or you can take it and sub it in here. As long as your math is done correctly, you should get the same answer either way, whichever equation you choose. So let's just stick with the first one. So we'll do y equals -2. In place of the x, we're going to sub in that 3, the answer that we just got, and then plus 14. All right, so -2 times 3 is -6. When I add 14 to that, I end up with 8. All right, so write your answer as an ordered pair, always x first and then y. And so that would be the answer that we get for number 7.